Greetings to the respective lecturer of Integrated Design Project 1, Semester 2, Session 2020-2021. I'm Nurul Syazwani binti Samri. I'm from K16, in charge in the Department of Earthwork, and I have been working with my fellow members, Aisyah binti Said Ghaffar and Nur Ain Nadira binti Abdullah. Earthworks are part of any civil engineering project. Earthworks are engineering works created through the moving or processing of large amounts of soil or unformed rock. Cutting and filling are used to produce the desired topography. To reach the planned levels, earthwork is done to rearrange the topography of a site. Earthwork may be divided into 4 types in general. Number 1, initial clearance of vegetation and trees and stripping of soil. Number 2, excavation to form trenches or pits, known as confined excavations. Number 3, cuttings, known as open excavations. And number 4, construction of embankments and field areas. To summarize the job scope of Earthwork Department, we are in charge of work regarding to the earth and this work as follows. Number 1, establishing a proposed level. Number 2, calculate cut and fill volume. Number 3, produce cross-section. And number 4, calculate the slope stability. Project background. This project is focusing on a development of a commercial area located in Mukim Pulai, Nusajaya, Johor Bahru. This project is to give benefits and advantages to the residents. This is because the project is basically to provide an opportunity for the Johor residents to have their own house. This project is also to propose a medium-cost shop lot where the business of daily household to ease the community, especially who live within the area. We are required to design a development in Zone B. So this is the topographic plan of Zone B. Site inventory. Site inventory and analysis are steps that must be done in the design process to assess the existing conditions of the site and identify the resources and environmental conditions that might be impacted by the proposed development. It is done by site visit and record everything or all elements that exist in the plan. Thus, in the early design process, we have gathered useful information to ease the earthwork analysis afterwards. Based on the development plan that we have get from the lecturers, we found that the area is 90% covered by hill, and it is also mostly covered by the palm oil plantation. The highest point in this plan is 47.453 meter, and meanwhile the lowest point is 23.033 meter. The existing buildings occur on our site is residential area and shops. It also requires earth drain, culvert and drainage. Also, there is power line, water pipeline and manhole. And the natural features is Sungai Pulai River. Site analysis. Site analysis is an evaluation or judgment of features on the site. Once all the elements on the property are identified, the pros and cons of each element are then evaluated. This result is then used as a starting point for the development of environment-related strategies during the design process. Thus, we have divided it into 3 elements, which is hydrology, geology and climate. In hydrology, we assume that Sungai Pulai flow from the highest point to the lowest point. Geology, we classified the rock as rock with clay, silt and peat with gravel. And the palm oil plantation is a sandy clay with silty clay soil. And climate, tropical wet and dry throughout the season. Next, let's start with the first design requirements, which is to establishing the proposed level. Proposed level is set according to existing topography and contour of the site area. It is determined by the highest and lowest point of the particular area, and the formation level is the average reduced level of particular points, and it is done to balance cut and fill volume. A few factors were taken to be considered in our project while designing the proposed level. In our zone, we noticed there was a water point as the figure shown, hence the other proposed level need to be higher than this area to ensure the effective flow of rainwater from the highest to the lowest to avoid standing water pools. Hence, the water point will be the lowest level in the site. The next figure shows the proposed level layout in our development plan. It is assigned in the range of 41 meter to 25 meter. The next design requirement is cut and fill. In determining the proposed level, the main factor needed to be considered is the volume of cut and fill. cut and fill were applied to ensure the volume for both cut and fill is equivalent. The geometry that exceed the proposed level will be cut and lower ones will be filled. In designing cut and fill, it is not desirable, but in the first place, considering the volume of cut greater than volume of fill so that the import of material from the outside can be minimized or not required at all. Not only that, the percentage of difference between cut and fill volume is much less than 15% to avoid unnecessary cost of importing extra soil from the other place. For our calculation of cut and fill, we have decided to choose the grid method considering the simplicity in calculation. The grid method had to be done by labeling each space, and in our case, we have divided the development plan into 3 parts, part A, part B, and part C to ease our calculation. The grid method can be done as below. A 25 meter times 25 meter grid was drawn on the project plan. The reduced level of each corner was recorded. Calculate the average reduced level, and the area of grid was determined and calculated. Proposed level for each grid was determined by considering the average reduced level. The data were then tabulated into Microsoft Excel, and then step number 1 till 5 were repeated to calculate the other grid. And the volume of cut and fill will be obtained by the summation of the total cuts and fills for the site. Next is the example calculation using grid method. The grid area that we have assigned is 25 times 25, which is equal to 635 meters square. And then by taking each value from the corner, for this example, the top left is 42.13 meter, top right 42.31 meter, bottom left 41.95 meter, and the bottom right is 41.95 meter. Then we calculate the average reduced level by sum the value and divided it by 4, and then we get the 42.09 meter. Then from this we assign the proposed level is 41 meter, and then the difference height is calculated by subtracting the average height and proposed level, and then if the difference of height is positive, it is fill, and vice versa for cut. And then the volume can be obtained by the calculate different height and area. The figure shown is the example of Excel computation for the cut and fill volume calculation, where you can see the sum of the value is tabulated in the cut column and fill column. It is interpreted as the negative value will be the cut volume and the positive value will be the fill volume. This is the first trial of cut and fill volume, where we have assigned a proposed level for the specific grade. So at the first trial, we have calculated the percentage of difference, and we obtain amount of 52% of difference, which exceeds the allowable percentage of difference. Thus, we must do the second adjustment to obtain the value within the acceptable range, which is less than 15% of difference. After making an adjustment to the proposed level for each part and taking consideration of any factors, we came up with the second trial of cut and fill volume, which is a success because we obtained a percentage of difference of 6%, which is lower than the acceptable range of 15%. So it is acceptable, and we can continue our calculation by using this difference and the proposed level that have assigned in the second trial. Next, after the completion of the Excel computation of the cut and fill volume calculation, we have came out with the cut and fill site layout, where we sketch it manually, referring to the positive and negative value from the Excel, and this is the final result from the volume that we obtain by doing grid method. Move on to the third design requirement, which is cross-section. Cross-section is the another method to identify the cut and fill volume. The cross-section for both AA and BB is labeled, and it is to establish and visualize roughly the amount of cut and fill. Through the cross-section, it provides a useful visual summary of the estimation, which presents the cut and fill depths across the project in a very clear way. And for our project, the red graph represents the original level of Earth's surface, meanwhile the purple graph indicates the proposed level area. The figure shown is the final cross-section of AA and BB, where the circle that I have drawn is stated that if the red line is above the purple line, the area will be cut. Meanwhile, if the purple line is above the red line, the area is a field area. Apart from that, the cut soil will be used to fill up the field area, resulting in reducing the cost of the construction since no extra soil is needed. Design requirement that need to be fulfilled in the job scope of earthwork department is slope stability. Slope stability is an inclined slope that can withstand its own weight and external forces without experiencing displacement. It is done to ensure the stability of structures and prevent loss of human life and money. And the slope created by identify a difference of height between the one that proposed and the surrounding, and considered the globally stable if the calculated safety factor is greater than the factor safety assigned on the calculation. To calculate the slope stability, we use the Bishop method. This method satisfies vertical force equilibrium for each slide and overall moment equilibrium about the center of the circular trial surface. It is a series of interslices force. If the factor safety obtained is less than 1.3, it is represents a failure. Meanwhile, if it is exceed 1.5, it represents a stable slope. This is the equation of Bishop method that will be used to calculate the slope stability. Procedure in checking slope stability. So before continue to calculate the slope, we must identify the critical slope, and it is obtained by identify the highest difference of proposed level in the plan. As you can see, it is highlighted in red line is 41 meter and 30 meter of proposed level stand side by side. So it is selected as the critical slope because the slope has more than 11 meter difference of proposed level. Assumptions have been made to input into the calculation of slope, such as bulk density of soil equal to 14.5 kN meter cube, cohesion of soil 25 kN meter cube, friction angle 32 degree, and the factor of safety is 1.7 has been assigned. The figure shown a series of slope that has been drawn to obtain the factor safety that exceed or near to the one that we have assigned, which is 1.7. So the series of radius have been selected, which is 25 degree, 28 degree, and 30 degree. And the ratio is fixed, which is 1:1 ratio. Meanwhile, we obtain the acceptable factor safety when using the radius of 30 degree. And the formation of the slope, we have used a 4-4-3 formation to provide more stability to the slope that we have designed. The figure shown the Excel computation to calculate the slope. From the slope drawing before, we can obtain several items that can be used to calculate in the table, such as number 1, we can obtain angle, which is angle from the midpoint of slices and the line of the circle. And then the number 2 that we can obtain is area of the slices, and the third one we can obtain the width of the slices. So this is the example of calculation by using the radius of 30 degree and ratio 1:1. So we obtain 1.69, which is already near to 1.7 that we have assigned before. Through the slope stability analysis, several trials were made to reach the requirement needed. It results in a graph of factor safety versus radius as shown. The graph shows that when the radius of increasing, the factor safety is decreasing. The minimum factor of safety stated in Manual Saliran Mesra Alam Masma is 1.5 for man-made slope. Thus, factor of safety for all radius trials is more than 1.5, which means the slope stability passed the check. The minimum safety factor is 1.7, which is already more than 1.5, and the selection made was the third trial as it exceeds the preliminary assumption of the factor of safety. Therefore, the factor of safety for the slope is 1.7 with a radius of 30 degree. That's all from me for the major department of earthwork from K16. Thank you.